Good morning, buongiorno, Jaxx Vane Studio Live number 25. Live 3 times a week on Twitch. And working on our sailing simulator prototype. Let's see what the situation is after the weekend improvements. There were a couple of important things. The first thing, if you watched the stream from last time, you remember that we had the physics running in a single thread. And that meant that, let me put my volume down and this up, although it's a little bit annoying, the audio for this thing. So let me put it down. You really don't care about the audio for this thing. So if you remember last time, we were in a situation where we could run, I don't remember, probably 4 or less boats, something like that, 4 or 5, don't remember exactly, and it was slower than real time. The good news is now we can run the physics in multi-thread, and that was a huge boost because now I can run 20 boats in total. So some boats will start from the same position, and this is how it looks. So it's running 20 boats, and we are at 30% CPU occupation for this. So that means that we're running 3 times real time. So we're simulating 1 minute in like 20 seconds, something like that. And that's a good improvement, but the hope today is to do better than this. The other very, very big improvement was, you see, I changed the way the AI system works. So now we have the black boat, so this guy, and this guy is basically my coded controller for the foiling. So just to recap what is happening here, the boats are trying to start, go as fast as possible, get on foils, and if they get on a foil, they will go faster, right? And the AI is only controlling, the neural network AI is only controlling the foiling part. So basically it's changing the angle of attack of the foils in order to get the boat to fly and stay there in a flying trajectory without going too high. If they go too high, the boat will fall, right? If they stay in the water, they will go slow. So what is happening here, you see that the black boat is doing its job pretty well. This is what it looks like. So you can see here, this is the foil. So it means the boat is flying and is getting up to almost 50 knots in 1 minute. The other boats, however, are not. So the other boats, you see, they start flying and then they fly too much and then they fall and then they recover and then they fall and so on. So that slows them down, right? So what we want eventually is basically the AI to perform as good or better than our control boat. Last Friday, actually until yesterday, I was complaining, probably you remember, about the waves messing up the results. So what was happening was that even the control boat would have drastically different results from one run to another. And I thought that was because of the waves that the boat was encountering. It is because of that, but it was basically because of a bug. And the bug was in something called, in the way I was calculating deventilation. So the idea of ventilation is that as your foil is getting to the surface, air is getting on the top of the foil, and the foil is losing all its lift, right? So it's falling down into the water. The way I was calculating, okay, if a foil is ventilating, how it comes out from ventilation, right? The way I was doing it, it was like, okay, once the foil reaches a certain depth, it's not that is recovering, it's not that the ventilation is going completely away immediately, but it sort of gradually goes away. What was happening before was that the system was checking, okay, am I deeper than a particular depth? In that case, was reducing the value of the ventilation. What was happening in many situations was that the foil was ventilating. You were going for a little while under the depth for starting to deventilate. Then you could come up a little bit over that depth, and basically your value of ventilation will remain the same. So you will remain in this situation where your foils were half ventilating, which doesn't really exist in real life. So that will create a huge difference in performance, even on the control boat with the handwritten code. So once I fixed that, in a way that basically the deventilation is an event that gets triggered once you go at a certain depth. It will take a little bit of time, not much time, I think, I don't know, fractions of a second. But once the process starts, unless you go back into the surface, the process is going to end, right? So you're going to end up with a foil that is completely non-ventilating, right? And that not only fixed my problem, so you can see now I put pause, but you can see now from the speed of the control boat, we can see that the speed of the control boat is always reaching 48, 49, right? So the difference in the result of the control boat is minimal. And that means that also the difference in the result of the other boats is minimal. And that means that the AI can do a much better job in trying to come up with a solution, a good solution to try to catch this guy. Okay, so in this case, we started from basically random values, and it's going to take a while until this eventually will start to figure out what's the best topology and weight in the neural network to perform in a similar way as our control boat. Other things that I fixed in the system were due to the way the actual neural network was evaluated. Before, I was basically adding these genes that you can think about them like connections between neurons. And the way these genes were evaluated, the order they were evaluated was in the same order they were created, which is probably not optimal, right, to what we want to do. And what I did was that every time I create a new gene, so a new connection, what is happening is that all the connection gets sorted in a way where so you have like basically like three kinds of neurons, right? So you have your input neurons that will receive sort of like, you can think about sensors, right? So they sense something in the simulation. In this case, they're sensing the speed of the boat and the height of the boat over the water, right? So that's what their sensor is sensing. Then we have another kind of neuron, which is our output. So in this case, the output is the angle of the foils. And then we have some neurons in the middle that will change, how these values interact, right? And they're called, they could be called like hidden neurons. Somebody calls them bias neurons and so on. So the idea is that the way I organize the order of evaluations is that the hidden layers that have as an output an input neuron are the first to get evaluated. So I treat them a little bit like they're adding a starting value to the sensors, right? So they're the first that get evaluated. Then you get the evaluation of all the hidden layers and all the hidden layers and outputs that basically have a hidden layer as a target, right? So then you do all the ones in the middle, and then lastly you get the evaluation of the hidden layers or the other one that have as an output our output neurons, and that should provide a better result, hopefully. This sort of works, and I know because I let this run for about 40 minutes yesterday, which accounted for about 100, I don't remember now, 113 generations. And yesterday I wrote the code to actually save it. So basically we don't want to start every time from scratch and throw away our knowledge, the knowledge that the AI has accumulated, right? So the idea is that you run the AI training for a while, that produces a result of our neural network state, and then in theory, you can load it back and restart from there, right? And keep evolving, hopefully, the situation. The way this gets saved is a text file with our koala file format. So that's how it looks like, our saved. Hey Giuseppe, that's how it looks like. And so what we're going to do today, one thing that I want to say, probably I didn't say, is that the ventilation bug that I fixed really improved the gameplay even while playing, as a player, right? Because often I was getting into this situation, very frustrating situation, where the boat will just not come out of the water. And that was that situation where the foil will remain half ventilated, so it will go a little bit down and then a little bit up, but it will remain half ventilated. It didn't have enough lift to bring me out. And I couldn't understand why in those situations the boat will just not come out of the water anymore. Right now, the behavior is much more predictable, and playing is much more fun, to be honest. So probably later today I will do a couple of laps driving myself, even driving actually driving with the control of the sail is super fun, because you can basically how can I say it, like pitch the boat up in a way, so or make it roll on the side, so you can really overpower the sail and come up, with the boat doing like this, and then foiling, and going around the marks becomes really, really exciting, because you turn. Basically what is happening is that as you're turning into 90 degrees, you get this power. Hey Moonsy, okay, thanks for the follow. You get this wind power at the maximum every time you are at pretty much 90 degrees, right? And that will try to roll your boat. So as you go around, and Meatball, thank you very much for the follow. As you go around the mark, you get this boat coming out like this, rolling, and then you go more into the direction where you want to go, and it will settle down again. But if you work on the sail power, you can actually balance the boat much better. So gameplay is becoming really, really exciting, and watching the ghost boat that I record as I run, running is not running anymore like completely flat like it was before with the automatic system, but it's having all this kind of different angles to it as you're desperately trying to power the boat and get the speed high enough so you can foil. It's super exciting to watch it. Yesterday I got really excited. UI. What language surprised you presently in my life? Even if you don't... lately Zig, for sure. Zig, I love it. I totally love it. Zig. It's awesome. It's awesome. Sadly, it still doesn't have a good support for IDE, I mean Visual Studio Code. So you get super basic auto-completion that is based on the file. There is no code navigation and things like that. So that's the main reason, to be honest with you, that's the main reason why I didn't use it for this project. Otherwise, if Zig had the same IDE experience as Rust has, thanks to Rust Analyzer or CLion, probably this project will be using Zig instead of Rust. You know, that's how much I like it. It's basically, it's definitely less friction than Rust, right? So it doesn't have a borrow checker. All the variables in a struct are public. So it's more similar to C than Rust. So in a way, you can think about Zig is probably in a way could be similar to what Jonathan Blow is doing with Jai, maybe. The documentation is okay. Me, I just can't. I can't deal. For me, the problem is not really the language library documentation, which is nice to have. But it's really my code. My code grows so fast. I mean, if I write a function, right, and then I move to another file and I have to call that function, I already forgot what the parameters are. I have no clue. My memory is really that bad. So I rely heavily on the IDE to do that for me. It reminds me, okay, what's the name of the function? Okay, what is the first parameter? Yeah. And if I don't have that, it's like a constant slowdown. There's too much. Because I'm trying to do this stuff all by myself, I really need all the help that I can get. Check how fast we can move. Oh, yes. All right. All right. Now we can move with this super fast. Good. Good. So I can get into this position and watch them. All right. Okay. So let's get on with the real work. So. Let me. Right. That should be all there is to it. So that should initialize everything to what we saved. Let's try. So we should have the boats that go fast. The generation should be starting from 113. Let's see. Ha ha ha. Ha ha ha. Very funny. Very funny. Try again. Yeah. Now we're cooking. So let's see if we really have the good AI. They're not really that good. They're definitely the evolved one. Yeah, the result is still a little bit. They suck. Why they suck? Are we? Where's my to-do list? Let's say that this is done. Right. So improve mate selection. Right now, we're being a little bit too communist, whatever you want to call it, right? In this thing, where we're saying, right, okay, 50% of you, where is it? 50% of you will get to reproduce. And of this 50%, each one of you will have at least one kid. Right? That's what we're doing right now. We want to be a little bit more brutal with this, right? So the problem with this is that imagine if one guy is really good compared to the other, right? He will get pretty much exactly the same chance as the rest of the 50% of the population. And we don't want that, right? Because he's the alpha. He's the alpha guy. He's, you know, he can fuck whoever he wants. You know, he's Jason Momoa. So we want to make it the probability of being selected as a male mate is proportional to his score, right? Okay, so that's what we want to do. How we do that? I think the only way we can see that this works, we have to wait until we get one guy getting much better than the other, which is something, and suddenly there's nothing I can do. I have to sit and wait and hope that this will happen. I wonder if I can influence this somehow. I think I can. I can, for example, say, okay, maybe I can cheat 1 second and first we should see lots of zeros, right? When they mate. That's a bug that I don't understand. Okay. And it's for another day. Suddenly it's so rare. All right. So let's see the situation here. Boom. Okay. So how many times we have 0? Not many. Doesn't look like this thing is working. Rested into. Interestingly, how, oh shit. See, that's what you get when you run a debug build on a CPU intensive application. Haha, very funny. It's gonna take us 2 minutes to get to the end. Ah, there you go. So now we're seeing the guy being selected pretty much all the time. All right. 10 minutes watching them and see what happens. Sadly, theory it works, and then I can move to try to improve the performance a bit. I'm not sure I like this this way of working with artificial intelligence. what are my thoughts on Lua? I don't know. I never used it. I heard very good things for games that need scripted gameplay. For Assetto Corsa, I used Python to let people write their own, especially UI stuff. And the reason why I choose Python over Lua is that Python allows you to go outside of the sandbox you create. So you can, hold on. That was fast. So our 0 did a 732. He got to reproduce 1, 2, 3, 4 times. Not really that much. Like for example, number 1 reproduce 5 times. Anyway, let's see how it goes, because in theory, because that guy reproduced 5 times, we should have, well, they're better. You see, there is more of them now staying with a black boat. So it's like the guy that did 700 meters was the algorithm sort of gave him more. So that's promising. So they'll definitely I don't know, I don't want to be too optimistic, but it looks like always 3 or 4 boats going as fast as the black boat. And now they got worse. Now only 1 really remain with him, so one, 2, 3, 4 times he got to reproduce, while this loser at number 8 got to reproduce 1, 2, 3 times. What is this? Oh, that's lots of boat. That's lots of boat going with a... Well, I don't know. It looks to me like they are evolving faster than before. Now they got worse again. Is it? Actually, I forgot. I wanted to do a functionality. Probably I should do that. Loser reproduce more. Yeah. There is still something that we don't do for the neat algorithm, which is something called speciation. Very fascinating. So the idea is that in a situation where a mutation occurs and our individual creates a new gene or a new neuron, what is happening is that it is to be expected that that mutation will not give an immediate result, right? So you can add a neuron or a connection, but the connection might have a value, a weight that is completely bonkers because it's random, right? So that individual could be could become extinct super quickly, right? Because of that mutation. So the advantage, so maybe he got the right topology, but he didn't have the right weight and he didn't have the time to evolve it. So the idea of speciation in the neat algorithms is that you sort of protect different species, right? So the way you evolve the individuals is even more complex. So you look at, okay, how many species I have, and you try to keep species alive for a certain amount of time so they have the time to evolve their weights without being extinct instantly. The other day I was thinking, right now we have all this neural network is all based on multiplication and addition. I'm wondering if I should get away from the idea of replicating nature with neurons and try to actually evolve something that looks more like code, right? Something that looks more like an Unreal Engine blueprint, right? So you have a node, and that node could be an addition node, a subtraction node, a multiplication node. It could be an if node. So instead of having this graph of neurons, we have a tree of flow logic. Right, so literally the AI will write code, literally. I should check if somebody did that already. So instead of going neural network, well, this is very cool now. Now we have a lot of boats staying with the black one. The more runs, the more we have boats staying with the black one. This is very promising, very promising. I wonder if something like that already exists. If it already exists, I wonder what it will be called. It will be called neural network based on, I don't know. What could it be? A tree code? See, yes, as a syntax tree. That's exactly what I was thinking. I was actually going to write AST, abstract syntax tree. That's exactly what you want. You want the AI to evolve a program. As a tree. So the evaluation becomes a novel neural source code representation based on abstract syntax tree. This might be exactly what I was talking about. Fuck, I didn't invent it. Jesus, I didn't invent this. Because my impression is that, right, especially, we got all our debug, especially in a situation like this where we are trying to replicate a code execution that does something really, really, and it's going to be super cool, because imagine the potential that once you evolve a neural network, well, it's not going to be let's call it AST network, right? Once you evolve an AST network that does what you want, you can literally translate it into code and put it in your program. And it's going to be super fast. And but this is working. I mean, it's obvious. Is it? I was going to say it's obvious. Well, right now we have how many? 5 boats really with comparable? 6, because 2 were on the top of it. Right. What I wanted to do was a system. I want to be able to print debug messages instead of having to look at this. I want to be able to print debug messages on the screen. Ah, the margin. Okay, the margin is not 32, it's 2. It's just the margin. All right. That's good. Okay, so this is working. Now, we need something more complicated, because we need these informations to come from the physics. And this is very tricky. All right, okay, let me do that. Okay, I'm very happy about this. Right, that works. So we should see a message generation blah blah completed every time a generation completes, which will open me the door to get this without looking at the console. Thank you very much, V Prosodosimo. Bring us a party of 2. Sadly, yeah, generation 52 completed. That's working. It's also annoying. Yeah, every time we launch, you know, the result is pretty different. All right, so our best score is 773 for an average. I didn't say it. Right, average 403. 598. So the average fitness is definitely going up. The top performance, I don't think you can get much better than that. So I wouldn't expect the top performance to be much better than what we're seeing, 700 something. But the nice thing is, look how consistent is the improvement on the average. And now that I said it, it's gonna go back, isn't it? I said that. I said it's consistent, and boom, it went slightly back. Yeah. It can happen. I mean, you can have mutations that you only need a couple of boats that really stay behind to screw up the average. It could be just a mutation gone bad. But the trend is obvious. Right, so this is all very promising. Let me do the last thing, which is use my amazing graphical abilities to do a very, very cheap optimization. Right, okay, so let me, basically this is delete vertices. Right, what is happening is that the system is calculating buoyancy for these points that it's really a waste of time. I hope the system will keep working. do another one. All right, I think that's okay. That should work. All right, okay. Is it any faster? Is it any faster? And how much faster it is? It's okay. We went from 30 to 23. So yeah, small victory. Small victory for the humankind. So everything should happen slightly faster. Yeah, not bad, not bad, not bad. I think it was a good day. Well, guys, thank you very much for stopping by for this stream. If you watch this on YouTube, you can follow it on Twitch in real time, totally live 3 times a week, 10 a.m. Central European time. As I know it's not a time where many people are free to watch a stream, but that's the time where my brain works. I try to do some streams in the afternoon, but I just become more and more stupid with the day progressing, right? So my next stream is going to be next Wednesday. Again, 10 a.m. in the morning. Thanks you very much for watching this, and I will see you then. Bye-bye. Ciao, guys.